Okay, took a while, but we're finally back. I think the mic might be crazy loud. I don't know. It seems like it's going insane, but I don't know. I don't remember. It's been too long, honestly. Spent too many fucking days moving, but we're good now. Okay. So, where were we last time? We were talking about C-style array decay as the solution in the C language that C++ inherits from. I think we had just gotten to the meat of the idea that... What the fuck is... Oh, there's like... It doesn't matter. There's like paint or something on the table. That when we evaluate a C-style array, if it is being passed somewhere, then it is passed as a pointer. So when we evaluate it as an argument, when passing it into a function, it is actually evaluated as a pointer and passed by address. Which is, well, yeah, and it's also not a class, which makes sense. It doesn't have the member size member function, so we can't call size on it because it doesn't have size. What do we even want? It's like we could have a function that prints it, right? And it, what does it even take? Here's the question. I mean, I guess we'll just say well, it's been too long. I don't remember which. I'm pretty sure it means it's an array of constants. So we'll try both ways. I'm going to say constant array called, sure, array. Jesus. Does it not like it as an argument? What's happening here? Hold on. Oh, wait. Why did I don't know why I put that there. Oops. And then we'll just call it with... Okay. Now it actually got hot. Took a while, but finally the apartment's hot again. I'll just do the AC. Okay. Fan is on now. So let's create an array of constant integers, right? And then we'll just say 1, 2, 3, and then we'll pass it my array. Oops, I don't know why I did that. Okay, and then we'll just do set a reference value array. Because when it's evaluating array, it's not seeing something that is usable in a for each loop. Okay, still too hot. Try a different fan, we'll see. Or just put it on its max power. Okay. So remember this, yeah, we can't use for each loops for C-style arrays because when it's evaluated after it has been passed, once this guy is evaluated here, it's been passed as a pointer. And I think it's effectively passing it as a pointer to the first index in the C-style array. So in this case, I think it's actually it's passing a pointer to the first index, meaning a pointer to an integer, a constant integer. So it's reading this like this is not an array, and we would get the same issue if I passed just a straight up integer here, and then try to do a for each loop with the integer. Well, it requires a suitable begin function. Okay, so in a for each loop, excuse me, seems like arrays and vectors have, well, I mean, they're both arrays. Like, if we include vector, and then we just make a standard vector, sure, test, 1, 2, 3, sure, and then we can do test.begin. Oops, hold. Yeah, so it does have a begin function. Meanwhile, an individual integer obviously does not, because it's not a class, it's just a fundamental data type. But we could index through it regularly. The question here is, how do we pass the size of the array here so that when we receive it, we don't exceed the valid element, or the last element, basically. Make sure that we're only accessing valid memory. I'm not sure. I don't know if we can. I mean, we have to, but I mean, we could say if I increment the pointer, well, it's not. Well, actually, does it? I don't know if it dereferences it off the bat. So if we said output array, and then we did the same thing, we said, yeah, it is treating it like a pointer, right? Because it's able to dereference it. So are we going to get the address and then the value? We are. Okay, interesting. So if we pass a C-style array and then print the C-style array, it will print the address. And it probably doesn't matter what type this is. So we can make this of type, double. And then say 1.0, 2.0, 3.0. And then const double. It doesn't take that because the arguments are compatible. Yeah, because double to int is an arrowing conversion that it's going to catch, right? Isn't that the reason here? Oh, the point is it's saying because it's saying, hey, you were so it knows here that it can't even receive a C-style array. It can only receive the decayed version. So it's looking for one type of pointer, and we can't convert different types of pointers. They must match, just like references, because references are pointers. But we can do double, and we'll still get the address and then the value. And specifically, it's the first value because it's actually a pointer to this index. Okay. It's implicitly converted. I'm starting back again because it's been, I don't even know, it's been a good few days since I uploaded just because I've been moving for so long. Took way too long. How long has it been? Fuck. 4 days. Yeah, 6, 7, 8, 9. Damn. 4 days. Or was that on? I honestly don't even remember now. Oh, so 7, 8, 9. Okay, it's been 3 days and today's the 4th day. Damn. Down 6 hours of studying. Or, sorry, 9. It's used in an expression that's usually implicitly converted to a pointer to the first element. Yes, which makes sense. It's initialized to that element's address. That is called decay, array decay. And so we could say, oh yeah, that's what it was. So we could say, so we could create a C-style array, and we'll say const int, constant array, whatever, and it has some amount of things, 1, 2, 3, okay. And then we could say Oh yeah, I'm trying to remember how the equivalency worked, because we could say, is it equivalent to the address of array 0? I don't remember if you have to pass it and return it, or... I'm trying to see. Because these are two different types. So 1 is an actual integer. Because array 0 is an integer. Oh, sorry. How about the address of array 0? Oh, shit. Okay. But then if we check the second element, it's false. Okay, yeah. So if we evaluate this array, I think earlier I was having the issue because the identifiers were wrong or something like that. I remember creating an object, and I think it was about guns, and the names are wrong. It was like guns something instead of gun something. I just had the identifiers different. What? That's why they weren't recognizing each other. One was undefined. So we have an array here, a C-style array specifically. When we evaluate it, it decays to a pointer to its first element, its 0 element. So we get the address of 1 because it's a pointer, so it would need to be dereferenced to actually get the address of 1. And then, and we could also do no, that's it. So if we dereference, okay, that's it. We could do dereference array plus 1, or hold on, array plus 1. So we evaluate array to be the address of the first index. If we add 1, we should get the address of the next index, and we print it, we should get 2. We do. So we get 0 at first because we're checking it compared to the second index, not the first. So now we're going to get 1 and 2. Yep. Makes sense because we're adding 1. So we're saying, hey, this whole C-style array, when we pass it or when we evaluate it, it converts to a pointer to just the front guy, the front man. Squid Game style. But if I increment and I can dereference it to actually get the value, just like a pointer, because it is a pointer. But if I add 1 to it, it's pointing to the next element. So if there are 3 elements, we can point to the 0, the 1, and the 2. It's pointing to the 0 at first after the conversion. But if I add 1 to it, it's pointing to the second, the first element, the 1 element, the second, 1. And then if I dereference it, I get that one's value. So that's why we're able to add here, but we haven't done that yet. Oh, fuck. The fatigue set in, the tiredness. Oh, God. Oh. I don't know why I'm so tired. It might just be like physical fatigue from moving, and also just having not studied for 3 days out of practice like a bitch. Okay. Oh, and also, cool thing, when I do my soldering stuff, I have another table now because I'm fully moved in. So you can see that. Oh wait, actually I think this needs to be refreshed. Oh, that's why it's not shaking. Never mind, it's actually fine. It's just that you can see what I'm doing in the cam now. Well, let me make sure it's not falling off. It's sitting on top of a roll of paper towels. Let me actually see if I can configure real quick. Is there rotation? Tilt? No? Apply? No. Pan? Tilt. Okay, tilt doesn't work. That's it? Okay, is what it is. Alright, whatever. I was hoping I could rotate it a little, unless I can do that. I don't think I can do that here. Can I rotate? Nah, it doesn't matter. It's not relevant right now anyways. Do match them up. What is it, 240-ish? Yeah. 1 pixel. Okay. Boop. Back we go. So now I can record my soldering and any of the tech stuff that I'm doing. But I haven't done that in a little while because I've had to put it away and take it out every time, and I had to focus on this and then Unreal. So, but now I can do other stuff in the meantime. Okay. The C-style array is and I can record on my computer, so nothing will lag compared to my laptop. I hate recording on my laptop. It's terrible. Unless I'm on a plane. Alright, so we have a C-style array here of 5 elements. This is redundant. You may as well just put the 5 elements there anyways. That way if you change the elements, it's still good. It's just redundancy. And they're of integers, and they can be changed because it's non-const, seems like. And then if we say auto pointer array, we're curious to see what type of thing it deduces. And honestly, you may as well just put in array here instead of the type. But I mean, if I get the address of this guy, we know that that is a pointer to an integer because the address of operator returns a pointer to whatever the object we are giving it as its binary or as its unary operand, because the address of only takes 1 operand. So, we say the address of this guy, or well, the address of this guy is equivalent to just this guy. Why? Because he's decaying to the address of this guy. Boom. Or we could deduce from the array to see what it is, and boom, we see the same thing. We could deduce it and then dereference it, and we get 9. Or we could get the type ID to check what type it is. And it doesn't let us print out what the type is, but it does let us check equivalency. So if type ID of pointer is, well, the point here is we're saying, no, never mind. Type ID of pointer, it yields something. And then type ID of a pointer to an int yields something. And we can see, oh shit, a pointer to this is equivalent to this, which means this must also be a pointer to an int. This is the address. Oh, yeah, you could do that. You could do, I just did it the opposite way. I just dereferenced this guy and then said, is it equal to array 0? But you could do it either way. A normal pointer that holds the first element. Okay. Array, the address of. A const array decays into a pointer to const. Okay. That way if we pass it, we can't modify whatever's there. And let's try that. Trying to get this table to stop shifting. And you actually, and subscripting still works. We could also do the same thing by saying array plus 1 and dereference it. So we could say array plus 1 and dereference it. Oh, that's why I was doing that. Dereference array, or whoops, sorry, array plus 1 is 0. Oh shit. Okay, it's still, wait, hold on, not equivalency, it's assignment. That's where the issue comes in because it's not modifiable. Makes sense. Cool. But if we took const away, all of a sudden we're happy because it becomes modifiable. Or rather, it removes the non-modifiability, the constness. Oh, so what we subscripted, it's effectively dereferencing the pointer with the subscript being added to it. So if we're doing array brackets 0, 0 is added to the element, or 0 is added to the address, and then we dereference it. So it's the first element. But if we do subscript for 1, it adds 1, so it's not the 0, it's the second one. It's not the first element, it's the second element that we're then dereferencing. I wonder why size of and type ID specifically don't decay it. Maybe because it receives it in a way that doesn't yield this implicit conversion. Oh, that was good. When pass is a member of a class type. Meaning to initialize a class? Is that what we mean? If it's a member, it has to be a data member. And if we're passing it as a data member, it must mean that we're doing list initialization syntax. Just give me, for example, we could have we could say, yeah, sure. Oh, sorry, this is targets. Oh, because we can't. Wait, really? I can't even use. Oh, because it's a. Well, it says it's not decaying, right? So if we did this way. I'll hold. Are we unable to do it like this? Even then, huh? I mean, it's not a pointer to a const, so I'm not sure. I'm not sure. I haven't seen that yet. I gotta wait. Oh, I'm so tired. Okay. We can also pass it by reference. Oh, I think it needs... Doesn't it need this guy in parentheses? Hold. Where was this guy? Was it here? I don't remember where it was. I don't remember how we pass it. They are not pointers. It's a sequence. Indeed, it is a sequence of contiguous elements of the same type, and the pointer just holds an address of some type. Once decayed, it exhibits the int pointer type versus just being a type of a C-style array, an array of 5 integers. Yeah, it makes sense. It does not know how long it's pointing to. Decay being our loss of precision in terms of losing the information for length. Okay, back. Yeah, so the array decays to this guy. We're adding to get this guy, and it's dereferencing it automatically. Just like outputting a reference to this would probably print 9 automatically without having to actually dereference it. Oh yeah, we saw this before. We had can we do it on well, I mean, we could do it on this type of array, but can we do it on other standard vector, standard array? I'm going to find out in a sec. const and array, and just call it array, and sure, it's initialized with 1, 2, 3, and we're outputting array 2. Oh wait, well it's not called array, so that doesn't help anybody. And now we're gonna get 3, okay? And now what if we do can't even type anymore, it's over for me. Standard array called array A. We'll say array A. 1, 2, 3. And then output array A 2. Oh shit. So it also works here, so we get 3 and we get 3. But not even what I really wanted. We could do a wait, hold. Oh, because we could have, well, oh, that's the point here. So we could say right on a pointer. Meaning we need a pointer to an element. So I guess we could say right, and then we could say a constant pointer called array, we'll just call it thing. And it's initialized with the address of array 3. Okay. And then we could output, well actually we wouldn't want to do that. We'd want to do we could just get the address of the, well, maybe not, huh? No, because it's not decaying. Well, yeah, if we pass it by address, it's getting the array, the address of this guy. But if we get the address of this guy, then we could output thing 2 and we're cooked. Because it means we're gonna get big number. Why? Because we have overflow. We're getting the address of the second element here, but then we're not subscripting 0, we're not subscripting 1, we're subscripting even above it. So this doesn't work, but if we do 1, it's no longer undefined behavior. Boom. It's like we're passing this guy's address. So if we add 1, if we subscript 0, this guy is 0, we get him. Or if we dereference it, we get him. If we subscript it with 1, we get the next guy. If we subscript it with 2, we get the next guy. But this guy isn't valid. Undefined behavior. When the pointer is holding something other than the first element? I'm not sure what you mean. Pointer arithmetic? Oh, okay, gotcha. Yeah, so I think it's probably about what I deduced, where we say, hey, if we're using a subscript, it's effectively adding the subscript to the address it's going to dereference when we dereference it. So if we subscript it with 2, it's adding 2 to whatever the element is. If we had subscripted it with 0, it would have added 0 and been that element, but if we had done 1, it would have been the next, and if we did 2, it would be 2 to the next. Damn, a lot of shit here. Array decay solves our C-style array passing issue. So 1, we don't have to make a copy of it because we simply pass the address of one of the first element. We don't know how to not overflow, but maybe we can find out. And maybe we can't, but maybe we can. And then, so not only do we not have to copy it, we can also accept any length of array. So it seems like it's redundant to even specify how long the array should be, because the valid length depends on the array that we're receiving. Meaning that if we have a function that takes a C-style array with 1,000 elements, well, it doesn't matter if it's taking, if we actually pass it an argument with 3 elements or 1,001 elements. It doesn't matter, because the validity of the index we use is determined by the array that we pass, not the function. So it seems like it's redundant to, or not, it seems like it might even be harmful to pass in like the array of 1,000, and then the person who's reading it thinks, oh, we can't index past 1,000, so we cap it at 1,000. But instead, or cap it at 999. Not true though. Now let me recharge for a sec. Okay. Yep, decays into a pointer. The pointer's holding the address of the first element. We know this, yes. Yep. Yep, so we aren't doing any crazy copying. We're just passing one address of one element. Yeah, so it's cheap. Now the question is the length. Different lengths. But when they're decayed, they're probably, yep. At first they're incompatible, but they both decay, meaning that when we evaluate the argument, we're passing a pointer, not this guy. The interesting thing is that the parameter, which is of that type, is able to receive the decayed version. Only thing is, without the length information, how do we avoid going out of bounds? Same type, different length, decay to the same way. Makes sense, because they lose whatever the number is. The size. The length. Print element 0, but receiving it as a pointer instead of receiving it as the element. I feel like we'd If we're subscripting, we may as well put in the subscript syntax, no? To make it make sense? Well, this is a pointer to const, not a const pointer. Sure, I mean, we could do it. I don't know why I would want to do it, though. I mean, I'm doing that just so we're handling null pointers. I mean, it's not going to be, but in case it was. We'll just do an int one. Boom. Two and one, yeah. Yeah, I could see that. From a C-style array of size 5 to a, or of constant integers to instead, or a C-style array of 5 constant integers to instead just a pointer to a constant. Okay. It's like I'm being fucking hypnotized or something, dude. What the fuck? Oh, I'm so tired. I think it's just too hot. I think I have to put the AC back on. I cranked it to 76 because 74 felt cold for some reason. Probably just because I've been used to the heat of moving. I'm putting it down to 74. I just can't. I'm about to fall asleep. Oh. Alright. Let's get on a good luck hat. Close enough. Come on. Where's it at? It's right there. Oh, this. Alright, son, let's learn. Oh shit, hat, glasses, kind of meta. Okay. Yeah, we call this the prime arrays decaying from the array syntax, the C-style syntax, where we have the subscripts in the syntax, in the in the data type, to then be a pointer to a constant integer. Excuse me, that has arrays prime's first element. Excuse me. Same thing here, from this to this. Cool. And again, these are now, when they're decayed, they're just pointers to constant. And because that gets evaluated in argument form when it's being passed right here, it's determined right here. Oh, it's evaluated right here and it decayed. Boom. Now it gets passed into here as a pointer. Boom. Now we are adding 0 to whatever value it holds, which is some address. Well, that adds nothing to the value. So, boom, it's already pointing here or here, depending on what's passed, the first element, and indexes to be that. But if we had 1 here, I guess we'd want to check to make sure it's not valid, to make sure we're not accessing stupid shit. But if it's undefined, well, I mean, it doesn't check if it's undefined, though. That doesn't help us for there, because if it's out of bounds, it doesn't mean it's going to be null. So checking if it's non-null doesn't help. I mean, it stops crashing in some cases, but doesn't prevent undefined behavior. Okay. Need to get used to my, excuse me, new sink tap water because my fridge doesn't give water anymore. Oh, did they address at the first element? Yes. Those are the ones that are actually passed. Yes, because it's evaluated here and then received. Passed. Same shit. I prefer received instead of passed. It doesn't really matter how we're passing it usually. These are passing pointers of type const int, so a pointer to a constant. It needs to have a parameter of the same pointer type, meaning same pointer type, not a non-modifiable pointer type. It doesn't have to be a pointer type. It can be a C-style array. And here it comes. Here's the interesting part. That's what I'm about to say. I don't want to read that yet. Same type. We're subscripting the pointer to access the selected element. Sure, but it's weird. I don't like receiving it as a pointer and accessing it with array syntax, but having it be a pointer. It's like, I don't know. It's like pretend this is a reference. It was we're passing and receiving something by reference, but then we're using dereferencing just because it actually converts to a pointer and not a reference. No, I don't want to do that. I want to make it be a pointer then in that case, or make it be whatever. Wait, garbage truck? What am I hearing? Or in that case, if it was actually being converted to a reference, rather, and we're using reference syntax, then, well, let's see, what makes the most sense here? The point here is that it's actually converting to some underlying thing, so this syntax works, even though it's underlined or even though it's actually a pointer. So I would want to define this as however this is being used so that they're consistent and not be, oh, we're receiving a pointer. I mean, sure, if we're saying element here, then we know we're talking about an array, I think. But it's weird. I don't like having two things being array related, but then one not. I don't like that. Okay. We're subscripting the pointer to access the selected array element. Alright, head's too tight. I can't. Because the C-style array is passed by address. It has direct access, yes, so there's no copying. Yes, we already know that. Yeah, if we don't want to modify it, then sure, we make it make sense, make it constant. I mean, we have to if we're not. We have to if we're one. Like in this case, it has to be const. We can't make it be an integer because these convert to being a pointer to the first element, which is, oh, guess what? A fucking const int. We can't convert that to an bro, my perception is insane. Look at this. Big ass fucking ant on the wall. He goes. Ah! Ah! I thought I exploded him, but I did not. Fuck! I don't know where he went. He landed right between my fingers. Fuck. Alright, well, I gotta find him now. He's gonna kill me. I think I'm cooked. He's gonna bite me in my sleep. Damn it. I don't know where he came from. Crack in the wall, maybe? I don't see him. I'm tempted to just vacuum this area, but I don't see him moving, so guess I'll let him be. Oh. Am I good? I shouldn't have let ego get the best of me. I'm not gonna sit on his ass. Alright, we're good. Scared me. I felt it between my fingers. I thought I was gonna get bit. Alright. Yes, so duh, of course it needs to be of the same type. Subscripting the pointer. Because the C-style array is passed by address. The function has direct access to the array. Oh, there he is. I found him. Oh, he's wounded. He's right here. Now he's dead. And it's fine. Let me get tissue. Or, well, I'll do it just for the comedy. Let's switch to our handy dandy second camera. Put the second camera down. Or here, so I can get a paper towel and then go right back on top. And now we're back. And I will collect the ant. Part of them, can't even see it. There's the rest. Please do not come in here. This is not solo leveling. I can't level up, buddy. I don't want to fight you. Alright, be right back. Okie doke. Back to it. Deadly ant is dead. Knew I wasn't tripping. Okie doke. Fuck, I should have ordered lemonade. I'm craving lemonade now. Didn't get it in my last grocery order. Okay. Yes, it needs to have a parameter type that matches so we can actually fucking use it. Yes, because otherwise we're converting something that's not modifiable to being modifiable, and that breaks its constness, which is not allowed. Subscripting the pointer to access the selected array element, yes. If it's passed by address, yes. No copying, makes sense. Oh, here, this is where we were, okay. Thought we were here because it was talking about constness. Yes, make it const if we're not intending to, so that even in the case that prime and squares are integers and not const integer arrays, we can still use them. One problem, yes, exactly. It's not, see, I've been talking about this from the get-go. It's not obvious that it's supposed to be a pointer to an array of values instead of one value. Yep. Yes, I agree. I prefer to do the C-style version, the C-style syntax, not receiving it as a fucking pointer. Because then you have to know that it converts. Otherwise, Yes. Nice, that's what I have preferred this entire time. Cool. We'll interpret that as the same thing. Interesting. See, it's interesting how that's working though, because the point is that we have an object that when we evaluate it, it converts to the pointer type. So when we have the parameter that is not being converted to anything and it's not being evaluated right, I'm pretty sure we're just... Oh, am I good? Is this hair or is this bug? We're good. I just have hairs growing there. Okay. Just paranoid because the ant now. Right, I'm pretty sure we're making a copy to... We're just making a copy straight there. So we're copying from a pointer... So the address, we're copying the address over to this other object, but it's not a pointer. Instead of converting the pointer to the object type, like passing an integer to a double, the integer value is converted to a double because it can be via numeric conversion, which then gets assigned into or copied into the value we're talking, or into the parameter. In our case, it's not the passed thing that's being converted. It seems like it's actually the parameter, the receiving thing that's being converted from a pointer or from the C-style array to the pointer. But I guess CPP is aware of that. And so really it's just automatically converting it because there's no way to receive it. If there's no way to just receive the C-style, maybe as is, or if we're using C-style value syntax, meaning in integer array brackets, it knows that it's being passed by value, or at least being received by value, and if it is, it knows that it's decaying. And if it's decaying, we're talking a pointer here. Okay, let me check one thing. You're right. I've been waiting for this freaking pimple on my where the glasses touch nearly to be poppable, and it finally was. Finally. Alright, behaves the same. it will interpret it as the pointer. Okay. Excuse me. Communicating to the caller, that way we can actually see it. Yes. Still no length information required between them. Makes sense. So we may as well just put that there. Yep. May as well omit the length. Downside is it's less obvious that it's decayed. It makes us think, oh, maybe we're receiving as... So either you say we're operating on a C-style array that has been decayed, or we're operating on a pointer, and you just have to know that the C-style array was decayed. So it seems like either know something or like know what the syntax really means, or the syntax has to be totally different. What? What is this homework help shit? Jesus. Array syntax instead of pointer syntax. Okay. I am amenable to that. The downside, it's a good idea. Downside, it's less obvious that it's decayed. So we have to make sure to not do anything. Okay. I don't know what else you could do to it besides... I don't know. Is there something you can do to it that you can't do to the pointer version? I'm not sure. Problems. Here we go. It's clever. The loss of length. Oh, gotcha. Meaning that if it's a pointer, don't assume, or if it's an array, don't assume that there's going to be some, don't assume there's going to be bounds checking, because there isn't bounds checking. Not to mention, oh, gotcha, because if we do size of for the array, it's the array type, it's not decayed. It has multiple elements, versus a pointer, which just has whatever, however big a pointer is. Probably like an unsigned long. Unsigned long. Different lengths and without copying, we lose the length. So we lose bounds checking. Size of is also different because if we do size of here versus we do size of here. So if we do size of here, it's looking at it as an array and says, hey, 444. But here, it's saying, hey, you're a pointer to one int. You might be 4 or 8, something like that. Okay, it is 4 for a 32-bit address. Okay. Ideas were right. Good. Could be dangerous if we wanted to do different things, depending on the size of. So size of, or maybe we do size. Maybe we switch on the size of something. Using size of on a C-style array is potentially dangerous. Well, yeah, because otherwise it's only going to be a pointer to the element type. But if we do size of the array divided by the size of a pointer to it, it's dividing it by however many elements there are. So if we say, oh, hey, 3 elements, the whole size is 12, divided by the size of an element 4, there are 3 elements. Okay. But if it's already decayed, then we're getting a pointer to a pointer, which would be, what, 1? Size of array is a pointer. Makes sense. Well, yeah, that makes sense. Because we can only do size of before it's decayed. We can't do it after, yeah. Because we can. It will just give us the wrong thing. We're giving the size of a pointer to one object, a pointer to an element, instead of the actual object itself. That makes sense. And the issue there would be That's how we get the amount of it, the size. We can only do that in the function where the C style is created, unless we can pass it by value and then evaluate it. Or sorry, pass by reference so that there's no decay. Standard size will fail to compile if passed a pointer value. Oh, so we could do uh-oh, can't even use it. No overload, fails to compile because it doesn't match. Can't do it for a pointer, so. Alright, can't do standard size on a pointer. Compared to size of, okay. I never really touched size of. Yeah, for the signed value. Standard pointer diff T. Can't do it on a pointer. Cool. Says 3, but then when we print it, oh, guess what? Array decay is. Oh, we have a pointer. We're doing standard size on a pointer. Uh-oh, doesn't work. Array decay can make refactoring difficult. Meaning, like if we have a function that, okay, and so the point here is we're saying decay can be a pain. And maybe one example is we have an array that, like, if we converted, we were using a standard array, but then we switched to doing a C-style array. Well, if we were passing it as a reference or passing it even by value, we could have a for each loop that works on that array, that standard array. But if we switch to a C-style array, oh, it's decayed. Now it's no longer a C-style array. Now it is a decayed C-style array. It's a pointer. There's no begin and, well, actually, can you even do for each on a regular C-style? I don't actually know the answer to that. I mean, I'm guessing not, because if a C-style isn't its own class, then it can't have a member function, right? Really? Really, huh? So there's no begin. Interesting. So maybe it works differently. Maybe there are different overloads for, well, not even, well, yeah, I guess overloads for each loop. I don't know how those are implemented, but so that it behaves differently and uses the begin for here, but for C-style, there's another way of doing balance checking, maybe. Has to be. Yeah, if it works, it loops through like a little for each loop for a decay array. But then we pass it a decayed array now. Uh-oh, well now that for each loop doesn't work. Where would a silent malfunction happen? Well, maybe it still does something, like if we... I don't know. I was thinking about the bounds checking in loops, and the loop's still working based on the size, but getting undefined behavior because it starts to access indices that are out of range. And it would be able to tell not to use them if it's an undecayed array, but can't tell when it's a pointer, but I'm not sure. Because for a for loop, we say while the loop variable is less than the size, but if we can't get the size, then or yeah, I guess that's the point. It would silently compile. We're using standard. No, because standard size doesn't even work on a pointer, so it wouldn't work. Difficult to sanity check. Sanity check? Yeah. Ow. Oh, well, meaning if we're just printing the second index and we pass in one with 0, well, duh, yeah. We can't ensure it. Hello? No, sir, no, sir. Really? Well, then where are we getting the length from? Do we have a const expression integer, and now we have to manually put that in the array when we initialize it, and then we pass it along with it? Oh, we could just pass it with the standard size of it, huh? Oh, but then if we pass in the standard size and we pass it in, then we'll see, okay, passing in this array that's going to get decayed to a pointer to an int. I mean, I guess to a constant, sure. And then we're getting the standard size so that we can receive it as an int. I mean, this may as well just be a size t. And then that's what determines size anyway, I think. Well, actually, I guess it doesn't matter for a C style. Okay. And so we pass the size, but the size is 2, so we can't index it if it's less than... if the index is greater than the size. Yep. Meaning, so we could pass it in. Well, so we could say, yeah, right. So we'd say, well, I mean, sure, it could just be constant int array of size, whatever it has, 3, 2, and 1, and then we call void print array lm3, and it takes a const int array and standard size t size. And then we call print array element 3 with array and just standard size array. Hold. Oh, well, it's not checking here. It would just occur. But the point is we can do the checking, so we need CAssert. Or because everything's compile time, could static assert that size is hold. Oh, size has to be greater than 3. And this part doesn't matter. But it doesn't matter in this case because it's a static assert, so it's not going to give us the comment. But we could include CAssert. And really this should say okay, index element 3 is too small. Okay. What if we said size is nope, never mind. It's not gonna give the value. That would have been cool though. It's a pain. So the caller, whoever creates the C style, needs to know the size and pass the size in whenever we're using it like this. Okay. Make sure they're paired. Yeah, which makes sense that you would pass in the element or the array and then a size or standard size of the array. Yep. We're using standard size. Well, yeah, I mean, I'm just not going to do that. I would rather just make the size be whatever the size actually is, which is apparently a size t. Runtime asserts, yeah, so if we're talking about in debug, let's see. Oh, it makes sense, because if we do well, the problem is, so it would compile, but it would have to be run, and if something else determines at runtime what the size will be, well, yeah, but can't it not? Isn't the size already known at compile time? Oh, but, oh wait. Yeah, but right, can't we do a static assert on it? Hold. Wait, why can't we? What? So if this guy isn't known at compile time, I mean, what's the issue here? Oh, well, it isn't even known at compile time. Okay. So the solution here, would it not be template, making this a function template so we can use a non-type template parameter to pass it in at const expression, or pass it in as a const expression. So we can make a standard size t size, right? And then the question is if standard size returns, it does say const expression, so it should be able to return at compile time. And if it's passed in as a non-type template parameter, it should be forced to evaluate at compile time too. Right? Yeah, see, it's not that much of a pain in the ass. It's fine. Boom. And now the assert is failing. Unlike earlier, where I misinterpreted as not an assert failing, or not a static assert failing, but that the static assert can't even operate on it because the values on which it's operating are not known at compile time, so it can't check them at compile time in the first place. It's not, oh, they're evaluating to the wrong thing, the condition is false. No, the condition can't even be evaluated. Okay. It's not too bad. I'm gonna take this off. I don't want this to be in the way. Had this light. Okay. Since for making an explicit function call, if the function call is implicit, meaning that the operator with the array is an operand. Oh, gotcha. Meaning, well, if you overloaded an operator to do whatever you're doing, then I'm not sure how. I mean, I'm sure there's a way to do like multi-operator overloading or something, right? So that you don't have to just specify the left and right operands. You pass in the right and then the one to the right of that. Maybe not though. Maybe not. Can't you define your own tertiary operand? So you could do like seems like a pain though. It seems like a waste. All just for this. All just to keep using a C style. Just to be able to pass it in conveniently. Because if we do like standard character output, and we say that standard character output has a function or something, right? And we pass this guy in, but we call that function using the insertion operator. Well, there's nobody's passed in the standard size. Let me sit properly. If it is not semantically valid, excuse me. Hold on. Oh, meaning that we create the array with an invalid last element so that we go while the elements are valid. And we know that the end is terminated by some value, some unusable value that we can check, that we could say, right? And we'll say, well, I can't loop through it though. That's the problem. Oh, well, I can, right? So we could say, can I just say while true to loop through the entire array? And we could say if array Well, fuck, I need an index though. So what if we say in x, whatever, it's 0. And so we'll say if array x, whatever, is less than 0, then break. Otherwise, print array x and then increment x. Okay? So far so good? Alright. And now we could say a const int my array, and it's 1, 2, 3, 4, 5, 6, 7, -1. Okay, it always ends in the -1, and maybe we could define it, or we could say const expression int array terminator, and it's -1. And then we'll just say array terminator. And then we do print array, my array, boom. And we'll do this in the end of the line, and we'll say reached end of array. All right. That works. I mean, it's a pain in the ass though, because you have to append the length to the actual array. That's annoying. Okay. I'm going to work my way back into the regular study times. And we're going to go from second if there is. All right, that's good enough. Cool. Continuing shortly.